morning to all the 12th standard students of St. John's. Time and tide wait for no man. I think you will understand the meaning of this proverb and act accordingly. Don't waste your time. Read properly. Schedule your plan accordingly. Then follow the schedule perfectly. Now, we are in chapter 9 called Applications of Integration. We completed problem number 19 in the last class. And I told you that in integration, particularly in this topic, you have to observe each and every problem with care, because each and every problem are in a various methods. There is no similar type in any one of the two problems. If one problem is done in one way, you can easily understand the other problem is done in a totally different way. And only these problems will look like that. Even in integration, some exercises are there where we can follow the same procedure throughout the exercise. But now we are in a stage that we have to give utmost care to each and every problem because they are in different way. And another different model problem that we are going to see in this class, problem number 20. Evaluate this definite integral. I already told you definite integral means limit will be there, 0 to pi by 2. Then that is called definite integral, right? So we need to find the value of this integral. As I say, each and every sum is done in a specific manner. Here also we are going to do it in a separate way. The answer starts like this. Try to understand the answer. The first step, integral 0 to pi by 2. I am just writing 1 by cos square x divided by 1 by cos square x plus 5 plus 5. Can you guess how this comes into dx? The reason is multiply and divide, or I can write divide each term by cos square x. So this is our first step. I am dividing all the terms by cos square x. If I divide cos square x here, that will get cancelled, so only 5 remains. What is first step? Divide each and every term by cos square x, so this step comes. In the next line, this is equal to integral 0 to pi by 2. You know very well 1 by cos square can be written as secant square x divided by, again 1 by cos square is written as secant square x plus 5. We will understand this into dx. What we have done so far, 1 by cos square we have written as secant square. Here also 1 by cos square is written as secant square x, and then this plus 5. In the next step, we are going to use trigonometric formula. We know that 1 plus tan square x is equal to secant square x, right? 1 plus tan square x is equal to secant square x. So use this result here. So I am going to get this is equal to integral 0 to pi by 2. This I am not going to change. That will remain as secant square x. Only in the denominator, in place of writing secant square x, I am going to use this result. So 1 plus tan square x plus 5 into dx. Are you able to understand this? Now, this is equal to, again, integral 0 to pi by 2. This can be written as secant square x divided by tan square x plus 6 into dx. So what we did, first we divided all the term by cos square x, so that we got this step. And then 1 by cos square is written as secant square, 1 by cos square is written as secant square, and then using formula for secant square x. What is the formula for secant square x? 1 plus tan square x, that we are substituting here. And then adding the numbers, 5 plus 1 is 6, so we are writing tan square x plus 6. Now I am going to give a substitution here. I am going to integrate this using substitution method. dx is equal to differentiation of tan x is secant square x, right? So differentiating this with respect to x, so tan x will become secant square x. Now, if I cross multiply this, I'll be getting dt is equal to secant square x into dx. Just cross multiplying this to other side, we are getting dt is equal to secant square x dx. Now what I am doing here is, I am trying to convert all the x variable in terms of t. The variable x, I am trying to convert everything in terms of t. That is why just I am putting a substitution t is equal to tan x, so that if you see secant square x dx, secant square x dx will be converted to dt. So what we are doing, we are converting everything in terms of t. So when we do like that, when we change variables, we also should change the limits to that particular variable. If you see, the limit of x is 0 to pi by 2. The limit of x is 0 to pi by 2. But I am converting to t. So what I have to do, I should convert limit in terms of t. From x, the limit should be converted in terms of t. So, as I said, I have to convert the limit also in terms of from x to t, I have to convert the limit. So this is the substitution we have taken, t is equal to tan x. And the limit for x, if you see the integration, the limit for x is 0 to pi by 2. So limit for x is 0 to pi by 2. We need to find the limit of t. So what I am going to do, put x equal to 0 in place of, in this equation, tan 0 is 0. And tan pi by 2, tan 90 value is infinity, right? So we converted the limit from x to t. Next what I am going to do is substitute all these things in this first equation. This is nothing but the previous step that we have written. This is the previous step that is taken as first equation. So first equation now will turn to integral, limit is 0 to pi by 2, but the limit now we apply is 0 to infinity. So 0 to infinity. Secant square x dx is written as dt. Just refer the previous line. Secant square x dx is nothing but dt. Divided by the substitution that we have given is tan x equal to t. So this becomes t square plus 6. 6 can be written as root 6 whole square. What I am doing? Tan x is t. So this becomes t square. 6 is written as root 6 the whole square. Now what is the integration formula for this? Is there any integration formula for this? Yes, we know that. I'll write the formula here in the rough column. Integral dx by x square plus a square. And the formula says this is equal to 1 by a. I'll write the formula downwards. 1 by a tan inverse x by a. So this is the formula for this integration. You just compare these two. This is dx by x square plus a square. This is dt by t square plus root 6 whole square. So how to write it? And using the formula, this is equal to 1 by root 6. That is 1 by a. A is root 6. 1 by a tan inverse x by a. Here x is t. So t by root 6. And the limit is from 0 to infinity. This is lower limit and this is upper limit. So this we have integrated and written like this. First apply the upper limit. What happens? Upper limit is 1 by root 6. If you apply infinity, infinity by root 6 is also infinity. Tan inverse of infinity is nothing but 90 degree. So when you apply infinity in place of this, tan inverse infinity is pi by 2, 90 degree. So this is called upper limit minus lower limit. If I see 0 is the value, so if I substitute t as 0, tan inverse 0 is 0. So everything, that entire lower limit will become 0. So the final answer will be pi by 2 root 6. Hope you would have understood this problem. Just see whether you have any doubt here. Just we are applying the formula, that's all. This is the first equation. From the first equation we are substituting everything and converting x to t. And after that, this is the formula that we are applying. Integral dx by x square plus a square formula applying, then substituting upper limit first, then lower limit second, and we get the final answer as 5 by 2 root 6. Question number 21. You see similar kind of problem. This is evaluate 0 to pi by 2 dx by 5 plus 4 sine square x. Now, this and the previous problem are almost similar. So this is the first time that we are looking at the similar problems in this exercise. So as usual, the first step is you just try to understand what is the first step. I'll write the answer directly now. 1 by cos square x. If you see previous problem, same thing we did. Divided by 5 by cos square x plus 4 tan square x. Can you guess how this is? Into dx. The reason is, again, we are dividing each term by cos square x. Dividing each term by cos square x. So numerator divided by cos square x. Denominator, two terms, they both are divided by cos square x. And sin square x by cos square x is tan square x. That is why we have written tan square x there. In the next step, limit 0 to pi by 2. This will be written as secant square x, yes, right? Divided by, this is also 5 secant square x plus 4 tan square x into dx. Hope you would have understood. First step is dividing all the term by cos square x. Second term, writing 1 by cos square x as secant square x. So next step, what I am going to do is, this is equal to, again I am going to go for the help of a trigonometric formula. We know 1 plus tan square x is equal to secant square x, right? This is the formula that we know in trigonometry. Now I am going to apply, in place of secant square x, I am going to write 1 plus tan square x. So this is equal to 0 to pi by 2. Numerator remains secant square x dx. I am not using the formula for numerator, just observe carefully. Only for this secant square x, I am using the trigonometric formula called 1 plus tan square x. And then plus 4 tan square x, right? So to simplify, we will get 0 to pi by 2 secant square x dx. If I bring this 5 inside, what will happen? 5 tan square x. Here 4 tan square x. So combinedly I can write that as 9 tan square x plus 5. How this 5 comes? When it combines with 1, we will be having 5. Yes or no? In the next step, that is integral 0 to pi by 2. From the denominator, I am going to take 9 as common. So I will put 1 by 9 in front of the integral. What we are doing, taking 9 as common outside the integral. So that the remaining will be secant square x dx divided by, if 9 is taken out, what will be this? This will be tan square x. And 5, from 5 if I take 9 outside, what happens? It becomes 5 by 9, right? So like this, we got a step like this. Now in the next step, I am going to go for the substitution method as we did in the previous problem. Using substitution method. So using substitution method, t is equal to tan x. Actually the last step is taken as equation number 1. This is the last line. From here, this tan x is taken as t, differentiating with respect to x, dt by dx equal to tan x differentiation is secant square x. Cross multiplying, you will get this. I told previously that when we change one variable to other, that is when we change x variable, when we move from x variable to variable t, we should also change the limit from x to t. That is why this table is there. Limit of x is 0 to pi by 2, which is given in the question. Now we are converting to t. So put 0 here, tan 0 is 0. Put 90 degree here, tan 90 is infinity. So the limit of t is 0 to infinity. So combining all these things and substituting in the first equation, the first equation will turn like this. First equation becomes 1 by 9 outside, it is there, integral limit is 0 to pi by 2, but what I have to write 0 to infinity. So limit 0 to infinity secant square x dx, the name is dt. So dt divided by tan square x, tan x is taken as t, so this will be written as t square plus 5 by 9. I am going to write that as root 5 by 3 the whole square. 5 by 9 is written as root 5 by 3 whole square to match with the formula. What is the formula? Integral dx by x square plus a square is equal to 1 by a tan inverse x by a. So outside 1 by 9 is present. Here I am going to apply the formula 1 by a. What is a? Root 5 by 3 tan inverse x by a. Here x is t, a is root 5 by 3, and the limit is from 0 to infinity. Limit is from 0 to infinity. Now I can take this root 5 by 3 outside, so it becomes, if 3 comes up, it will get cancelled with 9, so it becomes root 5 or 1 by 3 root 5. Don't ask how it is. When 3 comes to the numerator, it gets cancelled with the 9, it becomes 3. Root 5 is present in the denominator. Inside the bracket, first upper limit. Upper limit means infinity. Put infinity in place of t. Entire thing will become infinity. Tan inverse infinity, answer is 90 degree. So pi by 2. This is upper limit. Minus. Apply lower limit. In place of t, put 0. It fully becomes 0. Tan inverse 0 is 0. So closing, this is upper limit minus lower limit. So what is the final answer? This is equal to, just multiply these two, you will be getting the final answer. What is the final answer? Pi by 6 root 5 is the final answer. Pi 2 into 3 is 6 root 5 is the final answer. So these two types of problems are looking like the same model. So this is the first time that we are seeing the same model problem. So try to understand. First step is dividing by cos square x. Second step is writing 1 by x cos square x as secant square x. Then what we are doing, using trigonometric formula, we are splitting, and then substitution method. Put t is equal to tan x, finding the limits and substituting, will get the answer. We will see the next sum in the next video.